All right, now you've had a good go at looking at binomial distribution questions with the previous videos. We're now going to have a look at what happens when you are asked to do an inverse binomial question. So for these, there are three parts involved. We have n, which is the number of trials, p, which is the probability of success. Of course, you've seen those two already. And for an inverse, we also need to know the probability that x equals 0. So this is the probability of having no successes whatsoever. So let's look at an example of how this actually works. What this means is we'll have information on 2 out of the 3 of those things, and we can use them to work out the other one. So I bought a 10 tulip bulb pack and planted them in my garden, and this packet gives a 99% guarantee that at least one of those bulbs will grow from those that packet of 10. From that, I can work out the probability of each of the bulb growing. So what does each bulb's chance stand at for it growing successfully? All right, so let's work through this. Start by writing down what you know. And I've just accidentally missed one there. So we know that n is 10. We've got number of trials as 10. And the chance that we have at least one of them being successful is 0.99, which means the chance that none of them are successful is 0.01. Now the formula for x equals 0 is simply the chance of failure, all of them failing, which is the same as saying 1 minus p. So that's the chance of failure, 1 minus p. And if all of them fail, that happens 10 times over. So that's to the power of 10. So we know that that equals 0.01. So then 1 minus p is the 10th root of 0.01. And our answer to that is 0.63096. So if 1 minus p is that, then p will be 1 minus 0.63096, which is 0.369 to 3 significant figures. That is our probability of success for each individual bulb. All right, so now let's look at an example the other way around, where we need to work out n. For this example, we have a peach farmer, and he produces and packages peaches for sale in packs. The chance of a peach being bruised in transit is 5%, so that's for each peach. How many peaches should he put in a pack if he wants to claim that there's an 80% chance that they will arrive with no bruised peaches in that pack? So again, let's start by writing down what we know, which is first that the probability of getting no bruised peaches in the pack needs to be 80% or 0.8. Then we also have the probability of success, or rather probability of bruising in this case, is 0.05. Okay, so using the formula, we know that 1 minus p to the n is equal to our probability of 0, so that'll be equal to 0.8. And the p is 0.05. So if we do 1 minus p, we get 0.95. So 0.95 to the n is equal to 0.8. Now at this point here, you can use equation solver on your graphics calculator to get straight to the answer. I will show you how to do it algebraically as well though. So what we do is we take log of both sides, but if you don't know logs, just use equation solver on your graphics calculator. Now I'm using the laws of logs to say that n is log 0.8 over log 0.95, and that comes to 4.35. Now, that is not a whole number, so we need to think about, do we need to make it to 4 or to 5 for the context of this question? So we want to be able to claim that there's an 80% chance. So try it out with n equals 4 or n equals 5 and see what happens. So just over to the side here, I've done that. I've checked this bit here. We want to be able to make that claim that it's 80%, so we can't undercook it. We've got to at least go over the 80%, so we need to just stick with 4 peaches in a pack. So that's our final answer.